My name is Jordan Wheeler. Today I'm going to show you how to make some complicated parts in Front Panel Express Designer from your SOLIDWORKS design. Let's get started. So here's the box I want to make today. This bottom box, it's a device box to hold a bunch of different things in here. You can see it's kind of complicated. And we want to make this in Front Panel Express. Why? Because it's fast mostly, but also very cheap. All right, so here's our box. You can get a DXF file, the outline, and start with that to make the initial front panel. But since it's just a simple square, I'll probably just define it 1.625 inches by 1.5 inches. Okay, let's go to the front panel designer. New, rectangular shape, inches, width 1.625, height 1.5. We're going to do 6 millimeters here, but really I want this actually to be made out of 1/4 inch thick copper. So I'll write down here, customer supplied blank 0.25 inch thick copper. And then I'll mail them a piece of copper off McMaster-Carr. This doesn't really matter. I like to select aluminum raw and hit OK. All right, so now we want to start importing stuff from SOLIDWORKS for our front panel. First thing I usually like to do is get all my through holes. So I'm going to click on both of these surfaces. I'm going to hit Export DXF here, and this doesn't really matter. And X-ray box, we're going to say this one has through. Okay, these two faces is what we're exporting. Okay, so now for this, all I want are my through holes. These are tapped holes, so we're going to delete everything that's not a through hole here, which is most everything. It's a tapped hole, that's a tapped hole. Okay, those are all my through holes. Let's save. Now we'll go over to Front Panel Designer. We're going to insert a free cavity here, free contour. Import the DXF file, X-ray box through, loading. Okay, these are too small for the 3 millimeter cutter. Suppose if you imported them as separate things, you could optimize this, so it would be like slightly cheaper if you use the 3 millimeter cutter instead of the 2 millimeter cutter, but that's really just not worth my time. Now it's in there, so selection. Now can we do an easy thing and align on the center here? Let's see, center, center, okay. So that's probably not properly aligned because you can see the center is not really the center of my box. So what I'm going to do is I'm going to align it, let's switch to inches, off a reference, one of these reference points here. So we're going to do of object, and then we're going to pick an object. Let's do this bottom left through hole. Which one is that? We were close. 6, 5. There it is. Okay. So now we just need to know where that is. So I know that it's in Y. It should be half of 3/16. So 3/32. Okay, and then, well, that was already aligned correctly. And in this, it's 1.625 divided by 2. It would be dead center, but we're off that by 1/4 inch, so minus 0.25. Okay, so now that's perfectly aligned. Let's click out of it. So what do we want to add next? We have this central cavity here to add, so maybe we'll do that next. We could export this as DXF and import it, but again, this is a pretty simple shape. I just know that it is 3/16 smaller than everything else. So that's 1 1/4 measure by 1 1/8, and the depth of that is 0.1 inches. Okay, so let's go ahead and drop a cavity in front panel. We're going to do rectangular, 1.25 wide, 1.125 high, depth 0.1, corner radius. So I think this is, that must just be whatever it is for the 3mm cutter. I usually make it a little bit bigger than that. Oh, here we go, millimeter. Yeah, so that's for the 3mm cutter. I like to make it a little bit bigger than that. And the reason for that is then it doesn't stop and then move on. It kind of goes to the turn continuously. And in theory, that makes it a little faster to machine. All right, aligning, distributing, center, center. Okay, that looks good. All right, so next we have a bunch of tapped holes. So these are all 256. So now I want to get all these tapped holes put down. And there's no easy way to do a whole bunch of tapped holes, bring them in from SOLIDWORKS into Front Panel Express. So what I'm going to do is I'm going to export them here as a DEF, tapped, save. Okay, and now we're going to get rid of everything on this DEF that's not a tapped hole, right? So let's get rid of our through holes from earlier. Move entities, move entities. Okay, there's all my tapped holes, quite a few. So let's save that. And then we'll go to Front Panel Express. So we're again going to import this thing, the tapped holes, right? Now, you can't just import tapped holes, right? Let's do, okay. So right now the tapped holes are 256, so they're too small for the 2mm cutter. So we're going to do as a cavity, and that allows us to go shallow. And then we're going to go down to a small cutter. Now we can see them all, right? And but we don't want through holes, right? We want tapped holes. So we're just going to do not produce object. Okay? And then selection, aligning and distributing. Let's try to center it. Yeah, since I have four nice holes on the outside, it gets nice and centered. So, right, so these will not be produced, but now we've imported a drawing that tells us exactly where to put our tapped holes. So basically, we can now insert a tapped hole, and I'll just zoom way in on one of these. Right, and I'll say, okay, I want to drop it right there. Oh, I missed a little bit, but that doesn't really matter. It's not that accurate anyway. Unified course, okay. 256. This, it can't go all the way through the quarter-inch material, so you do a blind hole. I basically want the depth to be maximum. Okay, 5.8 is the maximum, so let's write 5.8. Then we drop that. Okay, so now there's that tapped hole there. That is actually getting produced. So I'm just going to continue and do that. This is a lot better than measuring each one in SOLIDWORKS and then going back and typing in the coordinates exactly by hand. So you might say, oh, well, this is only accurate to how well you place your mouse, but that's actually pretty accurate. And at the same time, it's Front Panel Express, right? We're not expecting plus minus 1 mil precision out of this, right? We're expecting more like plus minus 10 mil precision. So I definitely can click better than 10 mils. Okay, that's all the tapped holes. Beautiful. So we also have backside machining, and we have this shape here. This is actually kind of tricky because this shape intersects with the edge here. If you put the DXF of this shape into this file, I'd actually want to cut it. Let's just do this one by hand. So what's the dimension on this? It's 0.55 inches, 0.45 inches, and measure, that is rotate, can't see it, quite see it here. 3025. Okay, so we want to drop that cavity in here. So let's do another cavity. Boom. Rectangular. We want to put this on the reverse side. We knew the height was 0.45 inches. The width was 3.025. No, 0.325, right? Better double check. 0.3025 divided by 2. But you can see the problem here is we have this cut, right? So basically we need to add on the radius here, which is 1.5 millimeters for the 3 millimeter cutter. So A plus 0.06. Okay, take that number. And okay, so now we know we need to add that onto this as well, right? Or minus it off, right? Or half that. There we go. Perfect. I get a nice cut there. And what was the depth we needed for that? So let's get back to it. Evaluate, measure. The depth is 1 inches. Depth is 0.11. Okay, so that's the whole box here made, except for we have some side machining, so we'll do that soon. But the other thing I like to do is, this is going to have a lidness in it too, so I want that to be a sharp edge. But I don't really like all the burrs you get on the front panel parts. So what I just do is I got to do rear machining anyway. So I do a 45 bevel, and I just put a 10 mil bevel on everything that I can. 45 bevel, 0.01. These I'm also going to do it. It's not going to work for the ones recessed in there. Bevel, 45. This one is in millimeters. So what's a 10 mils to millimeters? Okay, so we'll do 0.254. We'll just go ahead and put a bevel on the back here. 0.25. So it's not actually going to bevel these, and I'm paying to bevel them, even though it's just going to be cutting air pretty much. But the pavement is so little, it's not worth my time to optimize that. I don't want to bevel this inside corner, so that's pretty good. Everything there I want is beveled is beveled. Okay, so let's save that. And now we want to do some machining on each side of this. So what you want to do when you're doing the machining for that is you want to type in here, do not produce object. We're going to say left side X. What do we call this part? Left side X-ray DS box machining here. And we're going to rotate this. Do not produce. Hit OK. And then we'll move that. Oh. So you want to, this is just do not produce. This makes it very obvious to them where they need to do the machining. And so let's do that on the other side here. Right side X-ray TA box machining here. Okay. Let's edit that to make it. Let's make that the right angle, not 90, 270. Okay, and then we'll move it here. Okay, save. And then we want to do the edge machining here. So let's make a new front panel for that. New. It's going to be a rectangular shape. We know the width is, I said 1/4 inch copper, right? So we're going to do 0.25. And the height was 1.5. Thickness 10 millimeters. That way they know it's they're machining as deep as they can go. We'll do raw. And then we'll put in the marks for production. Left side of part X-ray TS box. Okay. And then my machining here, actually, if we look at the SOLIDWORKS for this, You can see that these are off center, their shape here. Now, since it's not symmetric, I want to make it very clear what is the top side here. So I'm going to say top side of part X-ray TDS box. Do not produce object. Let's rotate it 270. Boom. Zoom out. And we'll move it. Okay, now let's go back and look at our part. So I'm just going to measure these. I know this is a 40 mil diameter hole, and I need to know how far it is from the bottom. So we missed. .45 inches, measure 0.72. Let's go into here, let's drop a hole. Okay, diameter, inches, 40 mils, that's as small as they go. And we're just going to do whatever the max depth is. I got to go through 3/16 of material here. So 189 it says. 189 sounds good. 188. Okay, we know the position. Let's get into inches. Click out, click in. Oh, we missed again. Okay, the Y position was 0.45. The X position was 0.72 from that side, so it's 0.25 minus 0.072. All right, that looks good. Now we're going to drop our 256 holes. Thread, unified course, 256. Blind hole. I actually don't want this to go through the edge of that box, which is 3/16 thick. So we'll do something like 1.5 here. And we'll drop another one there. Okay, we know X should be 178, so let's put both of them at 178. And then let's find out what their Y values are. .2095. .6905. Okay, and since actually this part has a divot here, I'll probably just draw that on there, right, so that they don't miss it, so they know exactly what they're looking at, right? So I'll add a cavity. Do not produce. Depth. We're going to go to millimeters. We'll just do the max. Well, it's a cavity, right? So it's not the max depth. Let's do 79 millimeters. We want it to be rectangular. And the height is 0.45. Oops, inches. 0.45. The width was, I believe, was 0.11 deep. Corner radius is too large, so we'll just change the cutter here. This is just for, oh, it's too deep for that. Okay. Depth, well, whatever. We'll do 0.1, right? That'll allow us to do some small cutter. Radius entered is too large. Let's switch back to inch millimeters. Corner radius, 0.5 millimeter. Okay. X should be 0.11 divided by 2. Y, can't remember that. Let's measure it. .7385. So that should be 0.7385 plus half of 0.45 would be plus 0.225. Enter. That doesn't look quite right, does it? Let's see what it looks like. Oh, I mean, that is right. Yeah, so now they know, okay, that makes that very obvious, right? So save this as, you want to call it, you're not saving in the right spot. Left side of X-ray TS box. Save. And we'll basically just go ahead and do the same thing for the right side. We won't have this little cavity, but we'll very clearly try to state where the top is. And then you just order these all together. I'll ship them the piece of copper, and they'll do the side machining, and usually turns out pretty good. Do we want to have any bevels here? That's the last question. Should we bevel this? Front edges. Yeah, let's put a little bevel on it. It's a really small hole, so maybe I'll just do 0.05 mils on it. Just to deburr it there. The last thing I want to show you is once you've made your box, it's good to check that you didn't screw it all up. So what I like to do that is I go File, Export. We can save it as a step file. Get to the right place. X-ray TES box.step. Save. We go into SOLIDWORKS. We open it. File. Open. So we're looking for X-ray box TES.step. There it is. Open. Now we'll let SOLIDWORKS import it. Sure, we can run diagnostics on it. It appears there. Okay, I'm going to save this as file. I'm going to save it as a solid part here. X-ray TES box from front panel. Save. And then what I like to do is take that and go make assembly from part. Drop it in here, and then I want to drop my SOLIDWORKS version of it in here too. Oh, there it is. And then I'm going to basically align these, right? So let's mate that to that. Wrong way. Thank you. That's the side with the cut, so let's make that to this. Wrong mate alignment. Check. This to this. Okay, now we have them perfectly overlapped, and we can see if anything is not quite right. Since I selected 6 millimeters in front panel, the actual thickness is off a little bit. This is a little bit hard to look at, so what we do is we change the transparency on both of them. So now they're both transparent. Then you can just kind of see, did you do everything right? And actually, it looks like I dropped one of these holes incorrectly, right? That's not a line there. Must have misclicked. And looking at this is also the size of my cutout back here is not quite right. Normally I import the side things and look at them too. Looks like all the through holes are in the right place. All the other tapped holes are in the right place. You can see I actually changed these to 440s since I last recorded. So let's go see what we made a mistake here. Let's zoom in. Well, you can see I missed there. I'm not sure what happened there. Drill a hole. Okay. Now we're going to move it. Oops, cancel. That's how you move. It's a different program. Okay, let's grab it right in the middle. Okay, that fixes that. Let's look at this cavity. We have the height is 0.45. Let's go back to SOLIDWORKS. And let's remeasure that. 0.45. Height, 0.45. Well, this is a bit of a mystery to me. Oh, it's not that it's the wrong height, it's that it's misaligned. So let's get back to our assembly and have a look here. Is that what's going on? Ah, yes, so they're misaligned. So I got the Y value of that wrong. All right, let's double check it. Not that version, this version. Okay, maybe we'll measure actually from the center point here. Grab the center point, there it is. There it is. We got an edge stuck in there. Let's delete that. Should be 9635. 9635. Let's check. Y, 9 something else, eh? 9635. Oh, 0.9635. Okay, that looks nice and symmetric now. So that just shows you the easy way to catch any small errors you might have made. All right, thank you.